This is the screencast for section 2.6, example 4. What if the end behavior asymptote is not horizontal? What? It's crazy talk. So a slant asymptote is an end behavior asymptote of a rational function that is a slanted line, so a line that does not have slope 0. It is not horizontal. Example 4 asks us to find the asymptotes and intercepts of this function and graph the function. Okay. Asymptotes first, f of x equals x cubed over x squared minus 9. Now, I told you before that you had to do synthetic division or long division. I also told you you had to know about the degree in the numerator and degree in the denominator. Well, there's a reason why all that kind of works out. Your end behavior asymptote is going to be y equals x cubed over x squared. The first term in both the numerator and denominator reduced. This reduces x cubed divided by x squared reduces to x. So your slant asymptote is y equals x. Just like in the last example, if you took y equals x squared over y equals x squared, or y equals 2x squared over y equals x squared, those x squareds would cancel out if the degree in the numerator and the denominator were the same. So you're only looking at the first term. So my slant asymptote is y equals x. How about a vertical asymptote? We have two vertical asymptotes at x equals positive 3 and negative 3. They both make the denominator 0. So far, I've got 1, 2, 3, a vertical asymptote here. I've got another one at negative 3. And I've got this slant asymptote. What a mess. That does that. Alright, so now these boundaries will help me accurately sketch my graph. I'm going to get the graph from my calculator still, but now my sketch will be more accurate because I have all the vertical asymptotes and slant asymptotes marked. So now instead of this this kind of increasing to decreasing change down at the bottom left there in quadrant 3, instead of that floating out in the middle of the nowhere, I know where it is. It's right here by its boundaries. This next piece is going to come down from infinity away from the vertical asymptote at x equals negative 3 and then approach, come down from positive infinity and approach negative infinity, bordering each asymptote and also crossing through the origin. Oh, which reminds me, we need to find the intercepts. Duh. The y-intercept is when the y-coordinate equals 0, so really just the numerator equals 0. So that's at x equals 0. So 0, 0 is the y-intercept. The x-intercept, or intercepts, is when we plug in 0 for x. So f of 0 is going to be 0 cubed over 0 squared minus 9. That is 0 over, it doesn't matter. So the x-intercept and the y-intercept are the exact same point because at the origin we're intercepting both the x-axis and the y-axis. So I was right, it did go through the origin. Phew, that was close. Now the next piece of my graph that I can look at from my calculator fits into this little part between the slant asymptote and the vertical asymptote at x equals 3. The now try problem for example 4 is number 29. I need to find the asymptotes and intercepts of the function and graph the function. Okay, so first let's look at vertical asymptotes. Those are pretty easy. We've been doing those for a while in this course. So a vertical asymptote is going to make the denominator 0. That's x equals negative 2. Now as far as my other asymptotes are going to go, I need to look at the first term in the numerator and first term in the denominator. So y equals x squared over x, which will simplify to be just x. So there is a slant asymptote at y equals x. Now let's look at the y-intercept. The y-intercept occurs when we plug in 0 for x. So that's 0 squared minus 2 times 0 plus 3 all over 0 plus 2. That's going to be 0, 0, 3 halves. So when I plug in 0 for x, I get 3 halves on the y-axis, which is why that is a y-intercept. It's going to cross through the y-axis at 3 halves. Now for the x-intercept, I need to find out what makes the y value, what x values make the y value 0, meaning I need to find out what makes the numerator 0. Now this does not factor well, and if you do quadratic formula, you will find out that only imaginary numbers will make the right side equal 0, so I do not have any x-intercepts. So now I've got some valuable information that I can use to help graph. I've got a vertical asymptote at x equals -2. I've got a slant asymptote at y equals x. And I've got a y-intercept at 0, 3 halves. Now, these boundaries will help me accurately sketch the graph, but I am still going to need my calculator to see what this graph looks like. Okay, so I see this piece here. So I may as well put that down. We're going to come down from positive infinity along the vertical asymptote at x equals -2, and then come back around up to the slant asymptote. There was a minimum somewhere in there because we changed from decreasing to increasing. Now, is there nothing to the left of that asymptote then? So my domain is only -2 to infinity? Well, no, my domain is anything but -2. I can plug in anything but -2 there. So I must be missing something. So I'm going to hit trace, and I'm going to go to the left. Oh, look, see my y values? -14. So once I jumped over that vertical asymptote and my x values got to be further to the left, I can see that my y values are just lower. So I'm going to change my window, my y min to, I don't know, let's go with -20, see what I can see. Yep, there it is. So the rest of my graph is down here in that boundary. So it wasn't up too high, it was down too low. I couldn't see it. My y min wasn't low enough.